Hey y'all, welcome back to The Senses. We're going to start by talking about audition. But as you can see, before we start talking about audition, we need to discuss a little something about sound, right? Okay, so let's talk about the functional utility of sound. Like, what purpose does it serve other than music, which we all know and love so well? Okay, well, it helps you locate things. It carries information about where you are, where things are in relation to you. It helps you identify things. Sounds are pretty useful. It's late at night, you hear a weird noise, you listen to it a little bit more carefully, you're like, oh, that's just the tree scratching on the window, it's just the cat in the litter box, it's just a whatever. Um, it's also good for efficiency. Okay, um, well, it's not good for efficiency. Sound is efficient. It travels really well in air. Okay, so it's a type of information that we can sort of depend on, right? We don't have to touch something in order to get the information, the sound information from it. We don't have to smell it to get the sound information. It travels well through the air. Okay, now yes, there are echoes and reflections which do throw us off. But on the whole, it's a pretty efficient medium. It's also really good for vestibulation and balance. A couple of sound waves. When we say wave, we're referring to a sine wave. Okay, so you can see how the sine wave very much distinguishes different kinds of sounds. Not to say that I'd be able to show you sine waves and eventually you'd be able to tell me without, seeing this that, oh, that's glass breaking, that's teeth being brushed. I highly doubt that. But you can see where the waves get bigger, you can see where things are really happening, right? So here's a big rumble of thunder and it gets a little quieter as another big rumble, right? Okay, so it's all about the sine wave when it comes to sound. There's a couple of different measurements when we're talking about a sine wave. Frequency. So frequency is the number of cycles per second. Okay, so let me see. Let me get my. There we go. So if we're talking about cycles per second, if this is a second, right, this is the frequency of that sine wave. Okay, so we go through what? One, two, maybe two cycles per second. Now, amplitude is going to be height. How loud is it? So it's showing you right here. This is the amplitude. It's not from the bottom to the top. It's from sort of baseline. Different sounds are going to have different kinds of amplitudes, right? Amplitude, loudness is what you have to be careful for. So if you're standing right next to the bass amp in the club, things are going to happen that you cannot reverse. Okay, damage to the eardrum and tympanic membrane, as it's technically called, is permanent. So be careful with that. All right, these are the different amplitudes. I'm sorry, the different frequencies that are hearable, if you will, to different animals and humans alike. Okay, so this is the threshold. Remember what we mean when we say thresholds. How loud does it have to be? Okay, how high or low does the pitch have to be? Because we're talking about frequency here, in order for this particular species to hear it. All right, so let's look at the human. Okay, the human is going to be this line here. Okay, so low frequency. Okay, if it's a low frequency, it really needs to be a high amplitude, okay, in order for you to hear it. If it's a high frequency for humans, it also has to be a high amplitude. We sort of like things to be right about there, okay? That's where we like it. Okay, lowest threshold for human hearing. Okay, this is the pitch at which we can hear the best. Now look at the mouse. Super high frequencies, super low threshold. I'm sorry, is this a mouse? Am I looking at the right line? No, this is not the mouse. This is the dolphin. Whew, super high frequencies. It really doesn't take much for them to hear that. Okay, so the high-pitched noises that dolphins are making and the clicking and the such, right? We can't even hear half of what's going on there, okay? But they can. You can take a look at these other frequency to amplitude ratios. It's pretty interesting. Okay, phase. The phase is all about how far a wave is in its current cycle. So this is sort of a better demonstration. Okay, so we've got, if we consider that, let's take it at this point in time, right? So let's take it at this point in time here. This wave of traveling light, this red one, right? It's traveling at this point in time. This is where it's in its phase. This is the point in its wave phase that it is at. And this is the point that this blue one is at. And at this point in time, if you were to combine the waves, right, this is the point that their combined phases will result in. Okay, so it's a very much sort of gestalt. These two things sum up to something different, kind of an idea. Okay, so let's have a little bit of a demo. If I can find the demo. All right, so check it out. These down here, right, these are replicating what's going on up here. So you have a wave that's coming in from the left and a wave coming in from the right. And when they meet, check out how big that amplitude gets. So all the way up here, right? Now, the Doppler effect, different things like that, right? You've definitely heard how phases can change depending on what stage they're in, how far away they are from you, right? And phase is sort of what helps us to echolocate, if you will. So we get our binaural cues from phase differences. So let's see if I can kind of sort of illustrate this. So if we have one of those same kinds of waves, right? And it's coming from here. So it's going like this and like this. All right, there's our very poorly done sound wave. Okay, so here's this ear. Okay, by the time sound hits that ear, we're at that phase in the wave. When sound hits this ear, right, we're at this phase in the wave. Now, this may not be exactly correct, but hopefully you can sort of theoretically see what's going on here, is that there is a phase difference between the left and the right ear. And this phase difference is going to tell you what direction your sound is coming from. Okay? All right. So, that's the end of sound. I just sort of wanted to give you a quick little overview of how sound works and why it's important and why it gives us information. How it gives us information. So the next talk is going to be about actually processing sound waves. And I'll see you then.